morning, students. Current electricity, MCQs for JEE and Neet preparation. We will continue. Here it is. An electrical power line having total resistance of 2 ohm. So yes, R is equal to 2 ohm. An electrical power line is like this power line. Okay. Delivers 1 kilowatt at 220 volt, means here it delivers. It is point of supply. Here it delivers. Power P is equal to 1 kilowatt, means it is 1000 watt, and P is equal to it is 220 watt. Okay, resistance of this power line is 2 ohm. Your question is, what is the efficiency of transmission line? Now, first of all, what do you mean by efficiency? Okay, so efficiency is equal to output upon input into 100. And yes, it is general equation actually. Okay, here how to find efficiency? Efficiency is equal to output upon input into 100 means eta is equal to output power upon input power into 100. You are given output power, it is nothing but PO. Okay, 1 kilowatt. Yes, it is nothing but output power 1 kilowatt. You have to find PI. Okay, what power is supplied from here? So how to find that supplied power? Okay, in transmission line, what happens actually? Okay, due to resistance, there is loss of some power. So this input power is actually power loss during transmission. Plus output power. Clear about this? Okay, so yes, how to find this PI? For that, first of all, we have to find what is power loss. To find power loss, first of all, we have to find what is current flowing from this transmission line. Okay, a current from transmission line. What is current flowing from transmission line? For that, we will use this equation, that is P is equal to it is VI. Okay, so I is equal to it is PO upon V. PO, that is 1000, and V means it is 220 ampere. Okay, now resistance of this transmission wire is R. So therefore, power loss during transmission. P loss is equal to, it is I square R. It is 1000 upon 220 whole square, and R means here it is 2. So is equal to. Now how to solve this? Okay, yes, you have to calculate it directly, but I will calculate with the help of calculator. Okay, so it is 1000 into 1000 divided by 220 divided by 220 and into here it is 2. So it is 41.32 watt. Yes, it is 41.32 watt. So it is power loss. So what is input power from here? Okay, input power. What is input power? Input power PI is equal to P loss plus output power. Simple. Okay, so it is equal to P loss, it is 41.32 plus here it is 1000. So here it is 41.32 watt. That is input power. Now use equation of efficiency, that is eta is equal to output power, it is 1000 divided by input power, it is 1041.32, and here it is into 100. So eta is equal to what? I will calculate this. It is 1000 divided by 1041.32 is equal to 0.960, and into 100 is equal to, it is 96.032, means it is nearly 96%. It is nearly 96%. So yes, it is efficiency. It is efficiency of this transmission line. Clear? So yes, it is one easy question. Okay, how to find efficiency of transmission line. Okay, now next question. See, a wire of resistance R is bent to form a square ABCD shown in figure. You have to find the effective resistance between E and C, where E is midpoint of the arm C. A wire of resistance R. So first of all, I will assume that resistance of wire, let resistance of wire is, let resistance of wire is, resistance of wire actually it is given. Okay, I have to assume what is length of wire. Okay, actually I have to find what is length of water, because resistance to given. Okay, so see what is length of wire. So let length of wire is, that length of wire is, it is 4a. Why 4a? I will tell you. Okay, let length of wire is, it is 4a. Let length of wire is, it is 4a. And what is length of, sorry, what is length or resistance of wire? Yes, resistance of wire is R. So what is resistance per unit length? So yes, therefore resistance per unit length is, resistance per unit length, that is rho is equal to, it is R upon 4a. Simple. It is R upon 4a. Now you have to find what is effective resistance between E and C. Here it is E, here it is C, between these 2 points. So see, we can easily divide K. It is one part, okay, and it is second part. So let resistance of this part is R1 and resistance of this part is R2, and these both parts are in parallel connection. So how to find resistance of this part, that is E, D, A, B, C. Okay, resistance of part, resistance of part E, D, A, B, C, like this. Okay, that is R1 is equal to, yes, R1 is equal to, what is R1? If resistance per unit length is rho, then first of all we have to find what is length of this. See, I have assumed that length of wire is 4a, let length of wire from which this square is made, then we can say it is a, it is a, it is a, and it is also a. So this distance is, it is a by 2, this distance is also, it is a by 2. Clear about this? Then what is length of this part? E, D, A, B, C, A plus A, that is 3a. 3a plus a by 2. What is 3a plus a by 2? 3a plus a by 2. So it is 5a by 2. It is, sorry, 3 into 2, it is 6 plus 7. It is 7a by 2. Clear? So yes, what is length of this part? It is 7a by 2 into, what is resistance per unit length? It is R into 4a. A cut means it is 7 by 8. Yes, it is 7 by 8 R. Clear? Now, what is resistance of this part? EC. Resistance of part EC, that is R2. So R2 is equal to, it is, what is length of this part? It is a by 2. Then it is a by 2 into R upon 4a. A cut. So it is equal to, it is R by 8. is equal to, it is R by 8. And what happens, see, if you actually add these two, then you can easily find that their addition will be R. Yes, R. Okay, 7 by 8R plus 1 by 8R, it will be R. Now, as these two parts are in parallel connection between E and C, so equivalent resistance between E and C, the resistance between E and C, R dash is equal to, it is R1 R2 upon R1 plus R2. Okay, R1 R2 upon R1 plus R2. That how to find R1 R2. R1 R2 means it is 7 by 8R, 1 by 8R, and R1 plus R2. Hello, what is R1 plus R2? R1 plus R2, it will be directly R. Yes, so here it is R. So 1 R cut, 1 R cut. So is equal to, it is 7. 8 into 8, it is 64. So it is 7 divided by 64 R. Yes, it is 7 divided by 64 R. Clear about this? Okay, so yes, it is one easy question. Okay, how to find resistance of this E and C. Clear? Okay, two questions right now. We'll see some more questions. Okay, now next question, see. In the given circuit, an ideal voltmeter connected across 10 ohm resistance, okay, reads 2 volt. The internal resistance R of each cell, see, 15 ohm, 10 ohm, 2 ohm, 2 cells, they are connected in series of EMF 1.5 volt, 1.5 volt, R and R. Okay, how to solve this question? You are given K, voltmeter connected across the 10 ohm resistance reads 2 volt. So potential difference between two ends of this 10 volt, it is 2 volt. Yes. So what is current flowing from this? What is current flowing from this? We know that current is equal to, it is, hello, what is current? So yes, current is equal to current flowing from this. Current flowing from this, it is 2 divided by 10. That is, we can say it is 1 by 5. What is current flowing from this branch? As 15 ohm and 10 ohm, they are in parallel connection, potential difference between them is same. So current flowing from this, it is 2 by 50. It is 2 by 50. Okay, keep it 2 by 10. Okay, so to see, in this branch, current flowing is 2 by 50. In this branch, current flowing is 2 by 10 ampere. So what is total current flowing in this circuit? What is current flowing in this circuit? I. Then that current I is equal to, it is 2 by 15 plus. Here it is 2 by 10. Here it is 2 by 10. Okay. So yes, is equal to, it is 20 plus 30 divided by 150. So it is 50 divided by 150. It is 50 divided by 150. 0 cut, 0 cut. We can say it is 1 by 3 ampere. So yes, what is current flowing from this? I, that is 1 by 3 ampere I. Now, how to find K, what is internal resistance? We know in case of cell, what is equation of current? K, I, current flowing from circuit. Current flowing from circuit. I is equal to, it is E equivalent upon R plus R equivalent. Where I, that is current flowing from circuit, that is 1 by 3. E equivalent means what? Here, I can write this equation as E equivalent means this. See, these two cells are given in series connection and in helping condition. So in helping condition, what happens? That EMF acts. So it is 1.5 plus 1.5 divided by R, that is external resistance. Now yes, you have to find what is external resistance. So how to find external resistance? This 15 ohm and this 10 ohm, they are in parallel connection. So their equivalent is 15 into 10 upon 15 plus 10. So it is 150 divided by 15 plus 10. What is 15 plus 10? It is 25. It is 25. And now it is in series connection with this 2 ohm. Yes, you can simplify this. Okay, what is 150 divided by 25? What is 150 divided by 25? 150 divided by 25 is equal to, yes, it is 6, obviously. Okay, it is 6. Okay, then how to find this? So yes, it is visible is equal to, it is 6 ohm. Now this 6 ohm and this 2 ohm, they are in series connection. So it is 6 ohm plus 2 ohm is equal to, it is 8 ohm. So it is value of external resistance R. Okay, so yes, R plus R equivalent means this. It is R plus R. Clear about this? Okay, now yes, put value of I. Okay, what is equation of current? Equation of current, it is 1 by 3. 1.5, 1.5, it is 3. What is R? R is 8 plus here it is 2R. So now cross multiply. So 8 plus 2R, 8 plus 2R is equal to this 3 into 3, it is 9. 3 into 3, it is 9. So 2R is equal to, it is 1. So R is equal to, it is 0.5. Simple. R is equal to, it is 0.5. Internal resistance of each cell is 0.5 ohm. Yes, internal resistance of each cell, it is 0.5 ohm. Clear? So it is method, okay, how to solve MCQs. Okay, now next question. Okay, now next question. You are given one circuit. See, in this circuit, when the switch S is closed, then the value of current I will be. Now when switch is closed, like this, it is closed, okay, then here it is V is equal to 0. You are given, okay, at this point, we will use some name. At this point, let it is A, it is B, it is C, let it is point B. Okay, yes, you have to find what is current of I. What is current of I? Means this one I, okay. What is equation of current? Then yes, to solve this question, we will apply Kirchhoff's rule. How to apply Kirchhoff's rule? First of all, we will take path. Take path A to B to D. A to B to D. Okay. As we are starting from point A, at point A, what is potential? It is 20. Then it is minus 2I1. Then here it is minus 2I. N is equal to, it is V. N is equal to, it is V. Simple. So yes, therefore we can write 20 is equal to 2I1 plus 2I. 2I1 plus 2I. Or we can say 10 is equal to I1 plus I. Equation number 1. Now we will take this path. Okay, take path O. Take path CBD. CBD. What is path CBD? Then how to find? We take path CBD. For path CBD, we are starting from point C. So at point C, what is potential? It is 10. Then it is minus 4I2. Minus 4I2. Yes, I2. It is minus 4I2. Then here it is minus 2I. And again here it will be 0. Okay. So 10 is equal to 4I2 plus 2I. Now, as we have to find I1, see two equations. Here it is I1, here it is I2 and I. So how to find this? Yes, how to find this? I can replace this I2. See, at this point, if we apply junction rule, we can write I1 plus I2 is equal to I. So I2 is equal to I minus I1. I2 is equal to, it is I minus I1. So chalo, 10 is equal to 4. I minus I1 plus 2I. So 10 is equal to 4I minus 4I1 plus 2I. 4I minus 4I1 plus 2I. So 10 is equal to 4I plus 2I. It is 6I minus 4I1. Minus 4I1. Any doubt? Okay. Now, if we take common in this equation 2, then 5 is equal to, it is 3i minus 2i1 minus 2i1. Okay, that is equation number 2. And see, now you can say it is equation number 1. Why? Okay, I will give you answer. Now add this to equation number 1 and 2. Equation number 1 plus equation number 2. So it is 20 plus 5. It is 25. 2i1 minus 2i1. So i1 cut. Okay, then 2i plus 3i. So it is 5i. Okay, so I is equal to, it is 25 by 5. So I is equal to, it is 5 ampere. Yes, I is equal to, it is 5 ampere. And yes, it is your answer. Clear about this? So yes, this method, okay, how to solve such questions. Okay, it is easy. Barabar? So for today, this is it. Next question we will see in next lecture.